Look at direct and inverse variation. Okay, so just to make sure you know the definition of direct and inverse variation, let me unfreeze the screen first. If you have direct variation, and both of these are talking about the relationship between x and y. If you have direct variation, if x is increasing, y is also increasing. If x is decreasing, y is also decreasing. An easy way to remember that is x and y's are both going in the same direction. Inverse variation, they're just going to be going the opposite direction. So if x is increasing, y is decreasing, vice versa. In that box, you've got the two formulas for those two different situations. You've got direct variation, k times x, inverse variation, k divided by x. K is going to be a constant of variation. So let's kind of dissect that definition. What does constant mean? It stays the same. It's always there. So if your k value for a certain problem is 3, that 3 is not going to change. The x's and y's change, but the k does not change. Alright, so constant of variation. Variation means what? Different, okay, how things change. So your k value is constant as x and y changes. So just kind of think of that. Within each problem, and by each problem I mean whether it's direct or inverse, you need to know how to solve for k. So if I had to solve for k right there, what would I do on y equals k times x? Do what? Divide by x. So if you have a direct variation problem and you have to solve for k, you would do y divided by x. If it was inverse variation, what would you do? Y times x, or x times y, however you want to look at it. Okay? Alright, so now getting into the problems, you're going to be told whether, in the problem, it's going to tell you whether it's direct or inverse. Okay, the majority of the problems, you're not going to have to figure that out. I know the first problem that you'll see on the classwork page, you will, but usually those are pretty simple to figure out. So just kind of the basic structure of these problems is you're going to be given 2 points. You'll be given an x and a y, and in the other point you'll either be given x or you'll be given y, and you have to find the other. And that's it. Okay, so I think I'll try to simplify this process as much as I can. So looking at 1, says y varies directly with x. It says that y is 28 when x is 7. So there's one of my points. And then it says find x when y is 52. Whenever you're finding the k value, okay, make sure that you are using the x and the y that's in the same point, or same coordinate. I won't use the 7 and the 52. Some people kind of get that mixed up. So, if this is direct variation, to find k, am I going to do y divided by x or y times x? Y divided by x. So I'll do 28 over 7, which tells me that the k value is 4. Whenever you're asked to write the equation, you're always going to have y. You will always write y, you will always write x. And then you'll put whatever the value of k is. Alright, that equation is representing this situation. That means I can give you any y value or any x value, and you can tell me the other that goes with that. Alright, so on this specific one, we've got y, which is 52. So I'll plug 52 in for y, divide both sides by 4. X equals 13. Right. 52 divided by 4.
Oh, divided?
Yeah.
Actually,
Do what? X equals 13.
no. The or 52 equals 4x.
And then I divide both sides by 4. Solve for x. Alright, I do want to talk about... Now let's just go through the next problem first, then we'll talk about that. So it says, Julio's wages vary directly with the number of hours that he works. If his wages for 5 hours are $29.75, how much will he make for 30 hours? And then it tells you that X is the number of hours and Y is how much he's getting paid. Sometimes you will have to figure that part out by itself. It's not always going to tell you what X and what Y needs to represent. Hopefully this is a simple enough concept that you would understand that the number of hours determines how much you get paid. So the number of hours would be the independent, and then how much you would get paid is the dependent. I would recommend that especially on word problems, go off to the side and write those two coordinates like that, because as you're going through the process, you don't want to have to keep going into the paragraph to find information. I can do everything that I need knowing that it is direct variation and with what I have written there off to the side. So again, if this is direct variation, is it y divided by x or y times x? Divided by x. So I want you to find the k value, and then I want you to answer B and C. For your k value, you should have gotten 595. Here's the equation you should have gotten. And then the pay, is it 178 or 170? 178. 5. Okay. So again, hopefully that direct variation, hopefully that's pretty easy. Make sure that your answer makes sense on a lot of these, and I'll point out whenever we get to the different other kinds of problems. If he makes $29.75 working 5 hours, that means if he works 30 hours, is he going to make more than $29.75?
Yes.
Yes. If not, he needs to quit and get another job. Okay, so make sure that the answer that you get makes sense. Now, jumping back to problem number 1, I want to talk about this right here, that sentence that I have highlighted. The way that 99.9% of these problems are going to be written, whether it's one like that or if it's a word problem, the y value or the independent variable, it is going to be stated before you see the words varies directly. Okay? It should read just the way that reads. Y varies directly with x, even if it's words. Y varies directly with x. Okay, so that way if you have a word problem, kind of lost where I was at, but if you know how that is supposed to be worded, that means that if you have a word problem that whatever it's talking about in the problem, you don't really have any background knowledge of, you can still identify the dependent and independent variable. because dependent is before, varies directly or indirectly. X is after. Hopefully, number of hours and how much you make, hopefully you understand that concept, but if it's one that you don't, then you might be able to still identify your variable. So, let's go down here. We're going to do 2 and 4. Both of these are the inverse ones. So again, I'm going to set it up the exact same way. X is 4 when Y is 7. Find Y when X is negative 2. So, Chris, if I'm finding the K value, and it is inverse variation, is it Y times X or Y divided by X? If I'm doing an inverse variation problem and I need to find K, is it Y divided by X or Y times X? Y times X. So I would do 4 times 7, which is 28. Remember, whenever you're asked to write the equation, now if it's inverse, it's going to be divided by X. And then to find the Y value, because I'm given X, I'm just going to plug it in. So my Y is negative 14.
But I thought you said for inverse it's supposed to be opposite, because X is already negative.
Alright, so look at number 4. It says the frequency of a violin string's pitch, there's an extra word in there, varies inversely with the diameter of the string. So, again, you may have no background information about music, but if you can find where that word is right there, is the frequency, is that my dependent or independent variable? Is it the X or the Y? It's the Y. Y comes before this right here. So my frequency is Y. The diameter of the string is what? X. So if I look at A, it says if the diameter is 5 millimeters, the pitch is 500 hertz. If this is inverse variation, to find the K value, am I going to multiply or divide? I'm going to multiply. So your K value is 2,500. I want you to answer the next 2 questions.
166.67.
So let's look at this one right here. On these kind of problems, I call these give myself some space first. Okay. What I call these are 1 over alone, because the formula that we'll use is this right here, and let me explain what all this means exactly. But go ahead and write that up top. Okay, so whenever you're reading these problems, how you'll know that you've got one of these 1 over alone problems is it's going to talk about one person doing a certain job, whatever it is, another person doing this job, and then working on it together, doing the same job together. Okay, so you just kind of have to read through the story and realize that this is one of those. Whenever on this specific problem it talks about decorating 2 offices and how you're going to each one of those fractions, it's going to be You need to be thinking the number of jobs divided by the time it takes that person or those people to do that job. Now on this specific problem, it talks about decorating 2 offices. I want you to think of that as one job. So that's why it's 1 on the numerator. Down here, it's going to talk about painting 200 feet of fence. I want you to think of that painting 200 feet of fence as one job. Okay? Because I would rather you deal with 1 as your numerators than putting in 200 in each numerator. Or putting in 2. It's easier if you just do 1. Okay, so as long as the job is the same, which the majority of problems you'll see, as long as the job is the same from for each fraction, then you're just going to have 1 up there. And then below you'll have the time it takes either that one person or those people to do that. Okay, so on this problem, reading through it, it says Miss Pearl and Miss Harrod want to decorate their new offices. If Miss Pearl works alone, it will take her 2 hours. And if Miss Harrod works alone, it will take her 4 hours. How long will it take them to finish the job together? So, Miss Pearl, for her to do the one job, it said it took her 2 hours. It would take her 2 hours. If Miss Harrod works alone, it will take her 4 hours. And then it asks how long it would take them together, which we don't know. And so your equation is 1 over alone plus 1 over alone equals 1 over together. Of all the word problems that we have throughout the year, these are the kind of word problems that I get answers that don't make sense. Okay? If it takes one person 2 hours and it takes the other person 4 hours, if they're both doing the same one job, should it take more or less time than her? Less. Should it take more or less time than her? Who said less? Less. Okay? Because, just don't write this down. Let me just talk through this. This would be a problem where a lot of common answers that I would get would be 3 hours. Okay? Well, if Miss Pearl can do it in 2 hours, why would she want to work with Miss Harrod if it's going to take her longer to do the same job? Okay? The time it takes for the 2 people to do it together should always be less than the lowest time alone. Okay, does that make sense? Yes? Peyton, you're looking at me like, you good on that? Okay. So let's go through this and solve it. And there's 2 different ways you can do this. I'm going to show you. We're going to go through this one. The easiest way it is to solve the majority of the problems that you'll see of this kind, which we've already done both these ways in the previous class. This is actually an easier example of stuff we've already done. You can either find the common denominator of these 2, combine those fractions, and then you have a fraction equal to a fraction. You can cross multiply and solve. What I think will probably be the easiest way is you can find the common denominator for all 3 fractions, and then what can you do with the denominator? Do what?
Greatest common factor.
Okay, you want to find the greatest common factor, but once all 3 of them have the same denominator, you can just ignore the denominator. Okay, let's walk through it here. So, looking at 2, 4, and x, what would my common denominator be? 4x. Okay, I got to include the 4 here, or the x, because of that one right there. So I need to go to each fraction. 2 times what would give me 4x? 2x. So I've got to multiply the top and the bottom by 2x. 4 times what would give me 4x? X. X times what would give me 4x? 4. So I'll go ahead and multiply all those out. So I've got 2x over 4x plus x over 4x equals 4 over 4x. If all of my denominators are the same, I don't want you to think that you're canceling them out, but you can think of it as you can ignore the denominators, and you're just going to make a simple equation out of your numerators. So I would have 2x plus x equals 3x. Divide by 3. And if they work together, it would take them 1 1/3 hour. Okay, so let's go to number 2. Looking at number 2. So, same kind of idea here. Same kind of problem. It says, Ashley and Lindsay want to start a business painting fences. They figured out they could paint a 200-foot fence. Again, we're looking at that as one job. Don't put 200 on top of each numerator. They can do it together. They can do it in 40 minutes. So there's my together rate. Ashley can paint it in 70 minutes. How long would it take Lindsay to do it herself? Okay, so this is a little different in that they give us the together and they're asking for one of the alones. But the process is going to be the same. Oh. So, someone take a guess as to what my common denominator could be.
210.
Do what? 280.
210.
280x. Okay, and I want to talk about this because if you're really good with numbers, you can probably see that you could do 280x pretty easily. Okay? If you're not for sure where he got that, an easier way to get this, to get the common denominator, is just to multiply those three numbers together, which would be 2800x, 2800x. Okay, and I'm going to do it like that. Sean, are you going through it with 280x?
Yeah.
Okay, you keep working through that, and then I'm going to get your answer whenever I'm done up here. So, the common denominator that I'm going to use up here is if I multiply 70 times 40, that's going to give me 2,800. And then I've got x down there as well. Alright, and the reason why I say this is going to be simpler, because if you can look at this and remember how we got that, I'm going to kind of move that out of the way a little bit. I can look at each denominator and kind of going back, being kind of consistent with what we've learned already. I've got 70 here, so if I look at these three factors, which two am I missing? The x and what? If I have 70, which one of these three things is not 70? The 40 and the x. See how this is 70? And this is 70? Can we all agree that those numbers are both 70? Okay. This doesn't have 40 down here, does it? Right here? So I need 40 here. Does this have x down here? That's a letter. No, not an x down there. So I need 40 and I need x in that first denominator. So I'm going to multiply this one by 40x. Same question here. This one has x. So Connor, which two of these three things does that middle fraction need down there? 70 and 40. Alright, now if I know that that's 2800, I can just go ahead and write times 2800 there. Jessica, what does this last fraction need?
A 70x.
The 70x. And then now I can just go through and multiply all those out. So I've got 70x over 2800x plus 2800 over 2800x equals 70x over 2800x. And then now I can ignore my common denominator.
One question. Why did you form?
So on that, I'll subtract 40x. And then somebody tell me what 2800 divided by 30 is. Okay. Just so that we do all these 1 over alone problems in order, I added a certain one at the very end that you need to see how to work. So go there. It says, if John and Susan work on their homework together, it will take them 24 minutes. So there's my 1 over together. Susan works 3 times as fast as John. How long would it take John and Susan to complete the homework if they worked alone? So, if I was to write John and Susan's rate, it's still 1 over something. It's the one homework. That's the one job. What would Susan's rate be?
3x.
Think about it for a minute. Susan works twice as fast as John.
Oh, it's 3 times.
2x.
No.
What? It's 3 times, right?
As fast as John.
Third x.
Do what?
Third x.
Okay, instead of doing a third x, because that'll make
3y.
my head blow up, Susan's is going to be 1 over x. John's is going to be 3x. And let's think about this for a minute. Because if Susan works 3 times as fast, who's going to take longer to do the homework assignment? John is. So I want to take the time that Susan has, and I'm going to multiply it by however faster Susan works to get John's. So if it takes Susan 10 minutes, it would take John 30 minutes. Okay? Oh. Okay. So, looking at this, what would my common denominator be? Okay. I could do 24x. I could also do now, if I'm going to write my common denominator like I was showing you, if you have just an x in one fraction, I wouldn't do x times x. You can. You'll still get the right answer. But if I already got x once, then I would do it like that. Okay? So, up here, I'm gonna work through it using 24x. If you like doing it like this, then do it like that. So looking at the first fraction, I've got x down there, so I've got to multiply both the top and the bottom by 24. That's going to give me 24x. The second fraction I need to multiply times 8. And the last one I need to multiply times x. The nice part of this kind of problem where it compares the rate of 2 people, it doesn't really give you the actual time. It's kind of hard to put together, but once you get it put together, at the very end, it's easy because usually you won't have to actually move stuff around. So all I'm going to have to do is 24 plus 8. Okay. So if that's X, is that Susan or is that John's time? Susan's. X was Susan. John would be 3 times that, so it would take him 96 minutes if he did the homework alone. Okay. So, we got those. If you'll jump back up to 4, the next 2 kind of problems, I don't think they won't take as long. These are probably the more lengthy ones. And so we'll look at those other 2 kind of problems that you'll see. So looking at 3. These are the ones where, and again, you'll have to read through the problem and kind of identify what the process is going to need to be. I'll usually call these percentages. Most of these problems are usually talking about sports because that's an easy way to pull some kind of statistic out. And it's saying that this certain athlete has this percentage on this stat and he wants to increase it to this percentage. Okay, pretty much every time it's going to be some kind of increase. And so that's how you know that you're dealing with this. So it says Dirk has made 15 out of 20 free throws. He needs to have a 90% free throw average to earn a bonus. How many free throws must he make in a row to improve his average to 90%? Okay, so right now he's at 15 over 20. Okay, free throws made over free throws attempted. That's how the percentage is calculated. But then he wants to know how many must he make to get to that 90%. So next to 15, I'm going to keep adding to 15 really until I can get it up to that 90%. But before he makes a free throw, he must first do what? Attempt it. Okay. Now, can somebody look up in the problem and tell me why those 2 numbers are going to be the same? And it's kind of an assumption up in the word problem. No.
You have made over attempted, so you're not obviously for how many times it's obviously right.
Kind of, but there's a certain part of the problem, and it's like 3 small words in a row. Okay? All these problems, there's going to be an assumption that, it's either going to say in a row or it's going to say consecutively, that he's going to shoot 5, he's going to make all 5. He's going to shoot 10, he's going to make all 10. Okay? So make sure that you know that you're not trying to find 2 different numbers for that. It's always going to be the same number. So I want to find out how many free throws must he make in a row to get to 90%. So what fraction represents 90%? Do what?
9 cents.
Okay. I would do 9/10. Okay. You can do 90 over 100 if you want to reduce that. I do need to emphasize something here. You can reduce the fraction that represents the percentage. Okay? You cannot reduce the fraction that represents the stat that it's talking about. That he's made 15 out of 20 free throws. Okay? Because if in JD's first 20 plate appearances in baseball season, if he's got 15 hits in those 20 appearances, but then I come up to him and I say, well, no, you only got 3 hits because I can reduce that. He's probably not going to be okay with that because he knows that he's actually gotten 15 hits. Okay, but make sure that you know you're not reducing the fraction, the part of the fraction that represents the actual statistic. Do not try to reduce that part, but the percentage you can. Okay. After this becomes really easy because it's a fraction equal to a fraction. And how do we solve those? Cross multiply. So 150 plus 10x equals 180 plus 9x subtract 9x, subtract 150, x equals 30. Pardon? Alright, last one. I think probably one of the easier ones. So this one that I just call average, it's talking about, most of them are talking about how much is a person's, it's usually talking about cost, average annual cost of a certain item that they own. And it's usually going to say that they originally bought it for this price, and then they're going to pay so much a month or so much a year in insurance or some kind of monthly or annually cost on top of that. Okay, so it says Remington purchased a new cell phone for $350 and added an annual warranty plan that will cost him $35 per year. In what year will Remington's average annual cost of owning the phone be? When will it be? $122.50. So remember, average is total over number of. This is annually, would be number of years. So we need to find the total first. How much did he pay initially for the cell phone? $350. Is that a one-time cost?
Yes.
Yes. How much is he going to pay per year for the warranty plan? Okay. And since he's going to be paying that every year, I got to put X over next to it, representing the number of years. And then I'll divide it by the number of years that he's owned it. I'll set that average equal to the cost of $122.50. Okay. Now look up here real quick before you write it down, because I'm going to erase it. What would be an easier way to solve this? Okay, yeah, possibly. There's a few ways to do it in the calculator, so yeah, you're right, probably right. But without the calculator. Sure, you need to phone a friend? Okay. How could I write 122.50 as a fraction? Put it over 1. And then I can just cross multiply. So I would have 122.5x is equal to 350 plus 35x. Then I want you to solve how many years would his average annual cost of this phone be. 122.5.